Hello guys! Welcome sa ating z-knowledgeTV. Okay, so in this video, ating pag-aaralan yung first topic natin para sa subject natin na Mathematics in the Modern World. So, our first topic is about nature of mathematics. So, ano ba yung mga topic natin na matutunan dito? So, patterns and numbers in nature and the world, the Fibonacci sequence, and the mathematics for our world. So, after successful completion of this unit, you should be able to identify patterns in nature and regularities in the world, articulate the importance of mathematics in one's life, argue about the nature of mathematics, what it is, how it is expressed, represented, and used. Express appreciation for mathematics as a human endeavor. Discuss how mathematics can be a useful tool in observing math patterns, in predicting the future behavior of the objects in nature. Discuss Fibonacci sequence and related concepts and identity. And identify real-life examples. Identify relationships in nature and find their logical connections to form generalizations and in return make predictions. And last, generate patterns by performing one or several mathematical operations repeatedly. So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started. So, let's proceed to our first lesson. So, about patterns and numbers in nature and the world. So, let's define first what is pattern. So, pattern defined as regular, repeated, recurring forms or signs. So, itong patterns na to is nakikita natin sa paligid-ligid. Okay? So, hindi lang natin siya ganun na pinapansin kasi sa ibang bagay tayo nakatuon. Pero, may mga bagay sa paligid natin na nagsasabi na mayroong different patterns na nagke-create. Okay? So, example. So, this is skyscraper. So, merong patterns na binibigay itong example natin, skyscrapers. Sa floor tiles. So, yung sa tiles natin, different patterns yung meron dyan. Maging sa shoelaces, so different patterns. Sa zebras, yung mga mark niya, so patterns yan. And then also sa snowflakes, so may mga patterns din dyan. So also, patterns defined as identify relationships and find logical connections to form generalizations and also make predictions. So, through patterns, pwede natin malaman o pwede natin masabi na kung ano yung possible mangyari in the future. Okay? So, let's take this example 1. So, which of the figures can be used to continue the series given below? Okay? So, in this figure, so, mapapansin natin na kung pag-aaralan natin yung directions ng bawat arrows, so pwede natin malaman kung ano yung susunod na figure. Isa to. Okay. So, let's try na i-analyze itong first row. So, sa first row, yung arrowhead natin is going east. Okay? So, then yung next box natin, so going southeast. Also, yung third box natin is going south. So, meaning, yung rotation nila is clockwise. So, dapat, kapag inanalyze natin tong second and third row, so, dapat, pares lang yung direction ng arrow natin, which is going clockwise. Okay, so let's proceed in this second row. So, yung second row natin, yung first box ay going south. The second box is going southwest. The third box is going west. So, meaning, yung rotation nila o yung direction nila is going clockwise pa rin. So, therefore, kung clockwise yung first row natin at clockwise din yung second row natin, so, malamang, dapat yung third row natin is going clockwise. Okay, so let's try to analyze this third row. So, yung first box natin is going north. Yung second box is going northeast. So, kung papapansin nyo, na yung first and second box natin is direction nila ay clockwise. So, therefore, kung pa-clockwise siya, so, ang susunod na arrowhead is nakaturo sa east. Okay? So, ano dun sa apat na choices natin yung nakaturo sa east? So, ang sagot natin ay letter D. Okay. So, how about this example 2? So, which of the figures can be used to continue the series given below? Okay. So, in this example, so kailangan natin i-analyze yung different figures o yung different objects. So, meron tayong square, meron tayong circle, at meron tayong arrow. Okay. So, alamin natin kung saang direction papunta yung different objects natin. So, start tayo kay square. Again, so meron tayong 3 rows. So unahin natin itong square. So, sa first row natin, sa unang box, ang square ay nasa upper left corner. Then, papunta niya sa second box, yung square natin is nasa middle na. Then, pagpunta natin sa third box natin, yung square natin is nasa upper right corner. So, meaning, yung galaw ng square natin is still going east. Or kung gusto nyong pa-rotate, so, sabi nyo na going clockwise. Next, punta tayo sa second row. So, again, para kay square, yung first square natin, para sa first box, is nasa gitna. Pero, nasa left siya. Pagpunta natin sa second box, punta na siya sa gitna. Pagpunta natin sa third box, punta na siya sa right. So, therefore, yung direction ng square natin is going east. Which is tumutugma dun sa first row natin. Next. So, syempre, kung going east yung dalawang row natin, so dapat, yung direction ng box natin dito sa third row natin is going east pa rin. Okay? So, for the first box, yung square natin is nasa left. Then, pumunta siya sa middle. And then, syempre, bilang prediction, so possible na yung square natin is pupunta sa right. So, which is nasa baba silang lahat. So, dapat, nasa baba rin dapat lahat ng box na o square na pipili natin. So, nandito siya part sa right. Sa bottom right corner. So, So, alin dito sa choices, yung ang square is nasa bottom right corner. So, lahat. So, ibig sabihin, hindi natin siya pwedeng gamitin. Okay, so next. So, para sa second object natin, which is yung circle. So, para sa first row, yung unang box, yung circle ay nasa bottom right corner. Then, papunta sa second box, nandun na siya sa uh, bottom left corner. Then, sa third box, nandun na siya sa upper left corner. So, ibig sabihin, umikot siya. Okay? Umikot siya ng pa-clockwise. Okay? So, next, sa second row, yung circle natin is nasa bottom left corner. Then, papunta siya sa second box, nasa bottom right corner. Then, sa third box, nasa upper right corner. So, meaning, umikot din siya. Kaya lang, pa-counterclockwise. So, sa third row, yung circle is nasa upper left corner. Then, pagdating sa second box, nasa upper right corner. So, meaning, gumagalaw pa rin siya. So, direction naman niya is pa-clockwise. So, therefore, kung clockwise ang direction niya, so, bilang prediction, so, yung circle, possible na pumunta sa bottom right corner. So, sa choices, alin di sa choices, yung ang circle is nasa bottom right corner. So, meron lang tayong A at C. So, therefore, kung sa unang guess natin para sa square, yung square is nasa bottom right corner, which is pwede rin sa A at C. And also, sa second object natin, yung circle is nasa bottom right corner. Therefore, tanggal na sa choices yung B at D. At yung A at C na lang ang pagpipili natin. So, para mas ma-sure tayo, tumaas yung probability ng pagpili natin. So, gamit natin yung arrow, which is yung third object natin. So, para sa first row, so yung arrow natin is nasa bottom left corner. Then, pumunta siya sa middle, pero nasa baba pa rin, at pumunta siya sa bottom right corner. So, meaning, yung direction ni arrow is going east. Then, kay middle naman, o sa second row natin, so, hindi nagbago yung direction ng arrow. So, lahat sila is nasa middle. Then, pagdating sa third row, yung first box natin, yung arrow is nasa upper right. Then, sa second box, punta siya sa middle. So, kung gumalaw yung arrow natin from right, punta sa gitna, so, ang direction na is going west. So, therefore, bilang prediction, so, ang arrow is possible na nandito, nasa upper left corner. So, alin sa dalawang choices na A at C natin, yung arrow is nasa upper left corner. So, nasa letter C. So, therefore, ang sagot natin ay letter C. So, next, for the third example, which of the figures can be used to continue the series given below? Okay. So, dito, pansinin nyo yung first, third, and fifth na dice natin. Okay? Then, tignan nyo yung nasa upper part nila. So, lahat sila is may tag 6 na circles. Tama? So, therefore, bilang prediction, so, alin sa choices, yung sa taas is may 6 na circles. So, it's either B or C. Okay? So, tanggal na sa choices natin yung A at D. Next. So, pansinin nyo naman yung bottom nung same pa rin, nung first, third, and fifth dice natin. Okay. So, pansinin nyo na yung bilang ng circles nila is increasing. So, kung meron tayong 2 sa first days natin, nadagdagan tayo ng isa, kaya naging 3 yung nasa third days natin, nadagdagan pa rin ng isa, kaya sa fifth days natin is naging 4. So, therefore, kung alternate sila, so, therefore, yung susunod dito sa dice na to, is dapat merong 5 dice, o 5 circle. So, alin sa B and C yung may 5 circle? So, ang sagot is letter C. Kasi yung letter C is tumama sa prediction natin na may 6 na circle siya sa taas at may 5 circle sa baba. Okay? So, next. What number comes next? So, dito naman, papansin nyo na yung numbers natin is counting in even number. Tama? So, kung nag-start siya ng 2, plus 2, 4, plus 2, 6, plus 2, 8, plus 2, 10, plus 2, 12. So, therefore, kung lahat sila adding by 2, or they are in even numbers, therefore, the next number will be 14. Okay? Kasi 12 plus 2 ay 14. Okay? So, that's the example ng kung paano natin makapag-predict ng different problems or different situations. So, these are the different types ng patterns. So, si Stewart is classify niya yung different patterns into 2 types. So, meron tayong tinatawag na fractals at chaos. So, ano ba itong fractal? So, fractal derived from the Latin word fractus, meaning broken or uneven. So, in our world, we are used to measuring things in the 3 dimensions of length, width, and depth. Also representative of different types of structure which exhibit self-similarity. So, kung itong fractal is nag-determine ng brokenness or uneven o yung paghahati, so, ang tinutukoy lang ni Stewart dito, na kapag hinati natin yung ibang bagay o isang bagay, so meron dapat na magsasabing may self-similarity yung dalawang object na yon na na-create. So, ano ba itong self-similarity? So, self-similarity in mathematics is an exactly or approximately similar to a part of itself. So, example is the whole has the same shape as one or more of the parts. So, a better example of such self-similarity in nature is a fern. So, which can readily be seen to be made up of what appear to be copies of itself at smaller and smaller scales. So, ito yung fern or sa Tagalog, pako. So, kung mapapansin nyo, bakit ito yung binigay na best example is dahil kapag daw yung fern hinati mo sa gitna, so yung isang side at isang side ay equal or similar. And then kapag itong isang part na to is hinati mo rin daw sa gitna, so yung side na to at yung side na to ay equal din. So therefore, hatiin mo man yan ng hatiin hanggang sa lumiit ng lumiit yung scale niya. So yung left and right side niya ay equal or similar. So that will be self-similarity. Okay, so ano naman yung chaos? So chaotic behavior obeys deterministic laws but is so irregular that to the untrained eye, it looks pretty much random. So, it's not complicated. Patternless behavior, it is much more subtle. So, chaos is apparently complicated, apparently patternless behavior that usually has a simple deterministic explanation. So, it is a pattern arising from random data or entities. So, ang ibig sabihin lang nito, kung yung fractal is kaya nating makadetermine ng similarities or ng pattern kapag hinati natin yung isang bagay. So, itong chaos is hindi natin maipaliwanag o hindi natin makuwanan ng different patterns dahil sa sobrang komplikado ng binibigay nito. Okay? So, meron tong random data which is mahirap na hindi natin ganun mabilis ma-determine. Okay? So, example is yung sa kalangitan. Okay? So, yung clouds na to, so nagbibigay ng patternless behavior. Okay? Which is hindi natin mapaliwanag kung ano yung possible na mangyari. So, possible ba na uulan? Or possible ba na makulimlim lang? Okay? Or possible ba na maggagabi lang? So, depende. Okay? So, hindi natin maipaliwanag o hindi natin masabi. So, kaya siya, isang example ng chaos. Kasi random data or entity siya, which is apparently patternless. So, hindi natin mapaliwanag. Okay? So, kung gusto nyo pang maintindihan yung chaos, so, pwede nyo basahin yung book ni Ian Stewart, which is Does God Play Dice? So, dito, mababasa natin yung mas higit na explanation pagdating kay chaos. Okay? So, kaya naman, let's focus here sa fractals lang. Okay, so some of the fractal mathematical patterns that we can find in nature are the existence of the following. So, parallel lines, symmetry, geometric shapes. So, sa parallel lines, it defined to stretch to infinity, neither converging nor diverging. So, sa nature, ito yung makikita natin. So, makikita natin yung parallel lines sa tiles, maging sa mga desert. Sa mga desert. Okay, so nakikreate yan ng different parallel lines. So, sa symmetry naman, is when a figure has two sides that are mirror images of one another. So, it would then be possible to draw an imaginary line through a picture of the object, and along either side, the image would look exactly the same. So, this line would be called line of symmetry. So, meron tayong two types ng symmetry. So, first is bilateral symmetry, in which an object has two sides that are mirror images of each other. So, the human body would be an excellent example of a living being that has bilateral symmetry. So, example niyan is ito. So, possible daw na ma-imagine natin na meron isang imaginary line na naghahati sa isang object. So, and then that object na hinati is yung isang side niya ay equal dun sa another side. So, that will be the bilateral symmetry. Next, ano naman yung radial symmetry? So, radial symmetry is where there is a center point and numerous lines of symmetry could be drawn. So, example niyan is this one. So, sa starfish, sa sunkiss, o sa orange, or maging sa mga flowers natin. So, ano ibig sabihin ng radial symmetry? So, ang ibig sabihin niya lang is meron daw certain point o a center point na dun sa object natin. Which is kapag intersectan natin ng different lines of symmetry, so, different object o different part ang pwedeng natin ma-acquire. Okay? And kapag hinati natin siya o nilagyan natin siya ng line of symmetry, so, parang kapag inikot natin siya, parang normal pa rin. Parang walang nangyari dun sa object na yon. Okay? So, example. So, kapag itong orange, so may center point siya, and then naglagay tayo ng line of symmetry. Okay? And then, isipin natin na yung this point, dito tayo nakafocus. So, kapag yan ni-rotate natin, so, parang wala rin nangyari. Bakit? Kasi yung point na to is halos katulad ng point na to. Tama? O maglagay tayo ng different line of symmetry. Then, try natin siyang ikot-ikutin. So, hindi natin masasabi na yung point na to is different sa point na to. Kasi almost they are similar. So, ayun ibig sabihin ni radial symmetry. Hatiin mo man siya natin ng different line of symmetry, yung object na i-create niya is similar dun sa different sides. Okay. So, in this example, or in this figure, i-differentiate kung si Patrick starfish ay example ba ng radial symmetry or yung mismong starfish lang. So, dito, si Patrick na starfish ay hindi natin masabing example ng radial symmetry. Dahil yung different sides niya, so yung different part ng body niya is hindi symmetrical. Okay? Unlike this starfish, so siya yung masabi natin example ng radial symmetry. So bakit? Kasi if you rotate the starfish, you can still achieve the same appearance as the original position. So this is known as the rotational symmetry or radial symmetry. And also, the smallest measurement of angle that a figure can be rotated while still preserving the original position is called the angle of rotation. So, that angle of rotation is that, ito yun. Okay? So, kapag meron, di ba ang radial symmetry natin, merong center point, and then meron tayong line of symmetry. Okay? And that line of symmetry is merong certain angle of rotation. So, pwedeng this part, isang malaki. So, angle yan. Or, pwedeng dito. Pwedeng dito. So, that is the angle of rotation ay pare-pareho. Ikut-ikutin mo man siya. Siya yung magsasabi na parang walang nangyari. Okay? Same pa rin yung original position niya. So, a more common way in describing rotational symmetry is by order of rotation. So, ano ba yung order of rotation? So, a figure has a rotational symmetry of order n or n-fold rotational symmetry if 1 over n of a complete turn leaves the figure unchanged. Or yung parang walang nagbago. So, yung formula natin is angle of rotation is equal to 360 degrees over n. So, wherein yung n, kung ilang fold yung pwede mo daw gawin. Example, dito sa snowflakes. So, dito sa snowflakes, so, meron tayong center point, meron tayong axis. Okay? So, ilang tupi ang pwede natin magawa sa kanya? So, using this axis, so, isang tupi na yun. Then, pakabila, dalawang tupi. So, next, dito naman sa rotation, sa axis na to. So, isang tupi. then pangalawang tupi. So, 4 na. So, next, dito naman sa axis na to, so, isang tupi, then pangalawang tupi. So, meron kang 6 na tupi o fold. So, therefore, kung may 6 ka, so, using this formula, so, 360 degrees divided by 6. So, therefore, meron kang angle of rotation na 60 degrees. So, meron ka daw 60 degrees dito, meron kang 60 rito, meron kang 60 rito, meron dito, dito, at dito. So, meron kang 1, 2, 3, 4, 5, 6. 6 na 60. So, which is the pattern on the snowflake repeat 6 times, indicating that there is a 6-fold symmetry. Using the formula, the angle of rotation is 60 degrees. So, next. So, how about in this example? So, why this use hexagon in making honeycomb and not any other polygons? So, bakit nga ba hexagon? Bakit hindi square? Bakit hindi pentagon? Bakit hindi nonagon? Bakit hindi decagon? Bakit hexagon? So, alamin natin yan. So, gamit ang packing problem. So, packing problem involve finding the optimum method of filling up a given space such as a cubic or spherical container. So, as a proof, so suppose you have a circles of radius 1 centimeter, each of which will then have an area of pi square centimeter. We are then going to fill a plane with these circles using square packing and hexagonal packing. So, unahin natin ang square packing. So, sabi, meron to tayong different circles na pwede nating ilagay sa square. So, ilang circle daw yung kayang magkasya dyan sa square. Okay? So, alamin natin. So, ang formula na gagamitin natin is area of a circle divided by area of a square. Then, multiply natin yun sa 100%. So, para malaman natin kung ilang percent ba yung capacity na kayang magkasya dito sa square. Okay. So, ano ba yung area ng circle muna? So, ang area ng circle ay pi r squared. Okay? So, ilang circle pwede? So, meron tayong isang buong circle na may radius na from its center. So, may radius na 1 centimeter. Meron ding another radius na 1 centimeter. So, saan itong 1 centimeter? Ito yung given. Next. So, from this point, papunta dito, so another 1 centimeter yan. Kasi radius yan ng circle. Para sa circle na to, ha. Then another 1, this part, another 1 centimeter. Okay? So, kaya kung mapapansin nyo, ilang circle yung kayang magkasya sa isang part na to. So, meron tayong isang circle at meron tayong dalawang kalahati. So, therefore, meron tayong dalawang circle. Tama, may dalawang circle na tayo. Next. Meron tayong isa pang kalahati. So, let's say, sabihin natin another 1 centimeter to. Okay, kasi radius lang to, ha. Then, sa baba naman, other 1 centimeter. So, meron tayong dalawang radius, which is nag-compose ng isang buong circle. So, ilang circle yung nadagdag? So, may isang circle. Okay, so nagamit natin itong part na to. Nagamit natin itong part na to. Maging ito. Maging ito. At ito. So, ano lang hindi pa natin nakikita? Itong apat na nasa corner. So, pansin nyo na yung part ng circle na to is 1/4. Tama? So, 1/4 lang ng circle. Eh, ilang 1/4 yan? Isa, dalawa, tatlo, apat. So, kung may apat kang 1/4, so kapag pinag-multiply mo yan, is makaka-create tayo ng isang circle. Tama? So, 4 times 1/4 is, cancel mo yan, 1 times 1, 1. So, therefore, may isa pa tayong circle. So, therefore, ilang circle yung meron tayo na kaya magkasya sa square? So, meron tayong 4 circles in total. So, therefore, kung ang area ng isang circle ay 4 pi r squared, then ang radius ay 1 centimeter squared. So, ang area natin ng isang circle lang ay pi centimeter squared. Eh, meron tayong apat na circles. So, i-multiply mo yan ng 4. So, therefore, ang total area, gawin natin, total area ng circle ay meron tayong 4 pi squared centimeters. So, ayun yung ilalagay natin sa numerator. So, paano naman sa denominator? Area ng square. Diba ang area ng square ay side square? So, kailangan natin malaman, ano ba yung side na to? Ano yung dimension ng side na to? Okay? So, ang square ay merong equal sides. So, kung ang side nito is 2, therefore, 2 rin to. Okay? So, ang tanong na lang, paano natin malaman kung ano yung sukat nito? So, balikan natin yung radius ng circle. Again, so meron tayong dalawang radius, which is nag-create tayo ng isang buong diameter. So, 1 plus 1 is 2. Then, meron tayong isang radius dito na merong 1. Meron tayong isang radius dito na merong 1. So, kung ang total ng isang buong to is 1 plus 2 plus 1, which is 4, which is equal din dito. Tama? So, kung 4 yan, eh, di ba ang square ay equal ang sides? So, therefore, dapat 4 din to. So, therefore, kung ang side ng square ay 4, so, 4, anong unit? Centimeter. Kasi, 1 centimeter plus 2 centimeter plus 1 centimeter. So, merong 4 centimeters. So, square natin yan. So, ang sagot natin is 4 squared ay 16. Then, centimeter times centimeter ay squared centimeter. Okay? So, kapag nilagyan natin itong 16 squared centimeters sa denominator, so, ganito yung kalalabasan. So, 4 pi square centimeters, which is na-compute natin, at 16 square centimeter times 100%. So, same yung unit, square centimeter sa denominator. So, cancel out na yan. So, matitira is 4 pi divided by 16. So, using calculator, okay, so makakuha tayo ng sagot na 78.5398%. So, ibig sabihin, meron daw 78% ang pwedeng magkasya dito sa square. Okay? So, paano naman kapag hexagonal? So, ilang circle kaya ang kaya magkasya sa isang hexagon? Okay? So, same pa rin yung formula na gagamitin natin. Kaso, sa denominator, imbis na square is hexagon. Kasi hexagon yung basehan natin. Again, so ang area ng circle ay pi r squared. Okay? So, alamin lang natin muna ilang circle yung kayang magkasya sa hexagon. Okay? So, meron tayo isang circle. So, may 1 circle na tayo. Ngayon, pansinin nyo yung part na to. So, ilang percentage kaya yung part ng circle ang pumasok sa hexagon natin. So, yung part na yan ay merong 1/3. Sabi sabihin, kung equal itong mga to, ito, equal, ito rin. So, kung lahat yan is may tago 1/3, so ilang 1/3 yan? 1, 2, 3, 4, 5, 6. So, merong 6. So, therefore, meron tayo 2 circles. Plus yung 1 natin, itong 10. So, therefore, meron tayong 3 circles in total na kayang magkasya dito sa hexagon natin. Okay? So, sasabihin natin, edi sure, alam na natin yung sagot kasi ang sagot na dyan is itong square. Kasi may 4 yung kayang magkasya. Unlike sa hexagon, 3 lang. So, hindi pa. Kasi, may naka-denominator pa. Okay? So, therefore, kung ang isang circle is may 1 cm na radius, so therefore, ang area ng isang circle ay same pa rin. Pi squared centimeter. Tapos, yung total ng circle, yung total area ng circle, ay i-multiply mo lang yan na kung ilang circles ka. So, meron kang 3. So, therefore, ang total area ng circle ay 3 pi squared centimeter. Okay. So, para naman sa area ng hexagon, so, gagamit natin yung formula ay, so, area ng hexagon ay 3 square root of 3 over 2 s squared, which is itong s ay yung sides ng hexagon. So, since ng hexagon is regular hexagon, so therefore, equal yung sides nila. Okay? So, ngayon, ang gawin natin is alamin kung ano ba yung dimension o sukat nitong isang side. Okay. So, dito, so yung point na to, hanggang sa point na to, siya yung radius ng circle na ito. At itong side na to, so siya naman yung radius ng circle na to. So, kung ang isang radius ay may 1 centimeter, so dahil may dalawa na tayong radius, so therefore, yung isang buong sukat na to ay merong 2 centimeter. So therefore, using this formula, so magiging 3 square root of 3 over 2 multiplied by 2 centimeter squared. So, mangyayari is 3 square root of 3 over 2 times 2 squared is 4, then centimeter squared. Okay, then 2 times 4, and then cancel natin to. So, magiging 1 to at magiging 2 to. So, therefore, 3 times 2 Okay lang na pag magmumultiply tayo ng may radical sign. So, ang pag-multiply lang natin is yung whole number, which is itong 2, at yung whole number na nasa labas ng radical, which is itong 3. So, pag pinag-multiply natin yan, magiging 6. Then, copy lang natin yung radical. Okay. So, therefore, ang area ng isang hexagon ay 6 square root of 3 squared centimeter. So, yun ilalagay natin dito. Okay? So, therefore, ganito na yung kalalabasan. Then, since na pares yung centimeter squared, so, cancel out na lang yan. So, using calculator, so, pag pinag-divide natin itong dalawang to, itong numerator at denominator, then minultiply sa 100%, so, makakuha tayo ng optimum method na 90.69%. So, kapag pinag-compare natin yung dalawang yan, okay, itong 78 at 90, so, ang mas malaki is itong part. So, therefore, yung hexagon, ang masasabi natin may kayang magkaroon o mag-fill up ng maximum o optimum na circle. Okay? So, kaya naman, para mas less yung spacing, kasi kung i-minus mo to sa 100%, so 100% minus 90.69, so, masabi natin, meron lang tayong 9.31% na space. Okay? So, ganyan lang kalit yung space na meron sa hexagonal. Kaya naman, masabi natin na matalino yung mga bees. Kasi kaya nilang i-maximize yung spacing nila. Okay? So, other geometric shapes. So, some naturally occurring things also show varied geometric shapes as follow. So, the sphere. So, another shape is the hexagons. And another shape is the cone. So, and other patterns, so aside from mathematics in nature, so patterns are also evident in man-made structures and everyday encounters. So, studying these patterns help us in identifying relationships and finding logical connections to form generalizations we can use to make sensible predictions. So, let's take a look at this pattern. So, meron tayong first phase, another phase, then sa third phase natin, umulit doon sa first phase natin. Pagdating sa fourth phase, katulad siya ng second phase. Sa fifth phase, katulad siya ng first and third. So, therefore, kung titignan natin ang pang-anim na phase, so, kung alternating sila na nangyari, so, ang possible na next phase nila ay yung ganitong itsura. Okay? So, that's another example ng pattern. Next, your junior high school mathematics presented you with various number sequences, namely arithmetic, geometric, and harmonic sequence. So they all required you to observe or solve the patterns that will describe the entire sequence in order to list succeeding terms. So however, not all sequences are arithmetic, geometric, or harmonic. So some are just sequences whose patterns are summarized by unique n-term formulas. So, ano nga ba yung arithmetic? Ano tong geometric? At ano tong harmonic? Okay? So, kung babalikan natin yung study natin sa mathematics, so, ang arithmetic, So, siya yung may formula na an is equal to a1 plus n minus 1 d. Okay? At meron din siyang sum na n over 2 times an plus a1. Okay? Wherein yung an signify ng last term, a1 first term, yung n is number of terms, yung d is the difference of terms. Next, sa geometric naman, ang formula natin dyan ay Tn is equal to T1 or n minus 1. Okay? So, meron din tayo sum yan. Okay? Na a1 minus a1 r raised to n over 1 minus r. Or equivalent din siya kung i-factor out natin yung a1. So, magiging 1 minus r raised to n over 1 minus r. Wherein yung Sn siya yung sum ng terms, yung a1 siya yung first term, yung r siya yung common ratio, n is number of terms. Okay? And then sa harmonic, kung si arithmetic, ang terms niya ay nakadepende kay difference. So, si harmonic is same din naman na gamitin tayong difference, pero yung terms niya is naka-reciprocal ng arithmetic natin. Okay? So, example, ang first term ni arithmetic ay 2, then second term is 4, then third term is 6. So, kay harmonic, so reciprocal yan. So, magiging 1/2, 1/4, 1/6. Okay? So, dito, meron tayong different patterns, which is may kinalaman sa difference of two terms and common ratio. So, pero may ilang terms tayo na kailangan pa natin mag-create ng sarili nating formula. So, assume the pattern shown by the square tiles below. So, papansin nyo na So, assume the pattern shown by the square tiles below. So, using these figures, so, ano kaya yung susunod na term? So, kung bawat terms ay iba-iba. Tama? So, parang walang pattern. So, kaya naman, kung itatanong sa atin to, what is the n-term formula for the number of tiles in the figure of the sequence? So, pwede natin i-analyze isa-isa. Okay? So, notice that. So, para sa second term, which is itong A2. So, A2 has 2 square tiles on each of its horizontal part. So, meron daw tayong dalawang tiles. So, isa, dalawa. Then, sa isa pang horizontal, so meron tayong isa, dalawa. Tama? Then, pagdating sa between them, so, sa pagitan nitong horizontal natin, is meron tayong isang tile. Next, pagdating naman sa third row natin, o third term, So, sa third term, nadagdagan tayo ng isang tile para sa horizontal. So, 1, 2, 3. Then, another one, 1, 2, 3. So, may tagtatlo na tile sa horizontals natin. At take note dito sa between nila, so nadagdagan. Kung dito may isa, so dito may dalawa. So, let's say A, B. Okay? So, naging dalawa na. So, pagdating sa fourth term, so, yung horizontals natin, nadagdagan din ng isang tile. So, kung tatlo to, ito, apat na. Maging sa taas na horizontal, apat na rin. At yung sa pagitan nila, is tatlo na. A, B, C. So, meron pa ng tatlo. Kaya naman, yung para makuha natin yung last term natin, which is yung AN. So, AN must have n squared tiles on each of its horizontal part, and n minus 1 squared tiles in between them. So, kung wari, si A4, siya yung last term natin. Okay? At yung horizontal niya, ang sasabihin mo sa kanya is siya yung n. So, para makuha mo si A3, okay, in terms dito kay A4 na ang horizontal term niya is n, so babawas ka ng isa. So, kaya naman, n minus 1. Para yung horizontal nila is 3. Para kung wari, 4 to, minus 1, so 3. So, meron kang 3 horizontal. Okay? So, paano naman yung sa between them? Yung AN must have n squared tiles on each of its horizontal part and n minus 1 squared tiles in between them. So, kaya kung papansin nyo, so kung pang ilang term siya, so ganun daw yung bilang ng tiles sa horizontal part. So, kunwari, A4. So, ang n niya ay 4. Tama? Itong n. 4. So, meaning, meron kang 4 tiles sa horizontal. 1, 2, 3, 4. 1, 2, 3, 4. So, kung A3, meron kang n na 3. So, ibig sabihin, meron kang 3 horizontal. 1, 2, 3. 1, 2, 3. Ganon din sa A2. So, pagdating naman sa between them, so, n minus 1 daw. Bakit? Kasi, kung papansin nyo rin, na kung sa A4, ang n natin is 4, minus 1, so, meron ka lang 3 nasa pagitan. Tama? 3. Kung sa A3 ka, at ang n mo is 3, minus 1, so, meron kang 2 lang. And, ganun din sa A2. Kaya kung i-write natin siya in the formula, so, para makuha natin yung sum ng buo, kung ilang bang tiles lahat yan, pagsamahin natin yung dalawang formula natin. Tama? Yung n mo para sa unang horizontal, yun, since na dalawang horizontal yan, isa, at pangalawa, so kaya nakamultiplied ng 2. So, plus, itong part na to. Which ang formula natin is n minus 1. Okay? So, therefore, pagsamahin natin sila, so, magiging 2n plus n minus 1. So, pagsamahin natin yung like term, so, itong n at itong n. So, pag pinagsama natin sila, magiging 3n. Tapos, minus 1. Kaya ang sagot natin sa AN ay 3n minus 1. Okay? So, example, ilang tiles daw meron tong A4. So, ko natin. So, A4 is equal to 3. Anong N? 4 minus 1. So, ang A4 natin ay 3 times 4 is 12 minus 1. So, therefore, ang A4 ay 11. So, kung kaya bibilangan natin kung ilang tiles lahat yan, so, dapat 11. Okay, so bilangan natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, therefore, 11 tiles yung meron dito. Okay? So, for example 5, how many times does the 8th figure have? So, kung meron tayong 8 na n, so substitute lang natin yan dito. So, magiging 3 times 8 minus 1. So, 3 times 8 ay 24 minus 1. Therefore, ang 8th figure natin ay may 23 na tiles. Okay? So, wala nga naman na mag-drawing ka pa ng hanggang 8. So, ubos ang oras mo. Kaya naman, sa example to, kailangan natin mag-create ng formula o mag-formulate ng formula. Okay, so therefore, the 8th figure has 23 tiles. So, paano naman kung backward? Kung meron ka namang 329 tiles, at kukunin mo yung pang ilang figure siya. Or kung anong figure daw yung merong 329 tiles. So, kung yung 329 tiles, siya yung last term mo. Eh, diba ang last term is yung an? So, using pa rin yung formula natin, na an is equal to 3n minus 1, wherein yung an mo is yung last term, which is 329. So, lagay mo lang yan dito. Okay? So, magiging ganda na siya. So, 329 is equal to 3n minus 1. Then, pagsamahin mo yung like terms, so, ibig sabihin, itong minus 1, ilalagay mo siya dun sa kabila. So, kung minus yan, paglipat niya sa kabilang side is magiging plus. Okay? Itong minus, magiging plus. Okay? Then, naiwan na mag-isa yung 3n sa side na to. So, therefore, 329 plus 1 is equal to 3n ay 330 is equal to 3n na. So, para maiwan nag-iisa yung n, so divide natin both side by 3. So, therefore, n is equal to 110. So, therefore, the 110th figure will have exactly 329 tiles. Okay, so other patterns is for the tiger's stripes and hyena's spot. So patterns exhibited in the external appearances of animals. So the tiger looks and hyena's spot, these seemingly random designs are believed to be governed by mathematical equation. Okay, this is the tiger stripes and the hyena spot. Okay? So sabi, according to the theory of Alan Turing, the chemical factors in the cell determine growth patterns. The influence factors like hair color. There are two chemical processes, reaction and diffusion. So kaya daw nagkaroon ng ganyang mga patterns sa katawan ng tigers at sa katawan ng hyenas dahil sa reaction and diffusion. Okay? So, sa sunflower, so looking at the sunflower, there is a definite pattern of clockwise and counterclockwise arc of spiral extending outward from the center of the flower. Okay? So, pwede ito tayo makapag-create ng pattern dyan by looking the spiral. Okay, ito yung nasa gitna. So, pansinin nyo, kung titigan nyo mabuti yan, yung itong nasa mga buto niya is pa-spiral yung ano yan, ikot. Okay? So, pwedeng clockwise, pwedeng counterclockwise. Next, sa snail shell. So, as the snails grow, their shells also expand proportionally. So, this process results in a refined spiral structure. It is called as a triangular spiral. So, ito yun. So, sabi, kada lumalaki daw tong snail, nag-expand din daw tong shell proportionally. So, basta, proportion siya dun sa katawan ng snail. Okay? So, for the flower petals, flowers are easily considered as things of beauty. So, flowers with 5 petals are said to be the most common. So, some number of petals are Fibonacci numbers. So, ano ba itong Fibonacci numbers? So, pag-aaralan to sa susunod nating topic. Okay? So, population growth. So, mathematics used to model population growth with the formula. A is equal to P times ERT, where yung A is the size of the population after it grows, P is the initial number of people, R is the rate of growth, T is the time, and E is the Euler's constant with an approximately value of 2.718. Okay, so sample in this graph. So mula daw sa year 2009 hanggang sa year 2020, lumalaki daw yung population ng tao sa Pilipinas. Okay? And that growth of population is nakaayon sa formulang ito. Okay, so example. So the exponential growth model is this equation. Describes the population of a city in the Philippines in thousands, 3 years after 1985. So, what was the population of the city in 1995? So, what will be the population in year 2017? So, unahin natin yung 1995. So, since our exponential growth model describes the population 3 years after 1995, so we consider na yung 1995 is may time na 0. Kasi, that year pa rin siya natin kukumputin. So, hindi siya 1996. Okay? Hindi siya naging 1996. Kundi, same pa rin na year 1995. Kaya naman, yung T natin is 0. So, using this equation, okay, substitute natin yung T na 0. Okay, itong T, substitute natin dito. Okay, then multiplying 0.02 sa 0. So, any number na i-multiply natin sa 0 ay 0. Tama? So, therefore, ganito yung mag-come up nating equation. And any number o any constant number, kasi itong E, constant number yan. Okay, yung E, constant number. Kasi meron siyang number na 2 point something. Constant yan. So, any number na naka-raise sa 0 ay 1. So, therefore, 3 times 1 na siya. 30 times 1. So, therefore, 30 times 1 ay 30. So, therefore, yung exponential growth para sa year 1995 ay merong 30,000. Next, we need to find A for the year 2017. So, to find T, we subtract 2017 and 1995. So, we can get T is equal to 22. So, which we then plug into our exponential growth model. From year 1995 to year 2017, meron daw 22 years. Okay? Then, ilalagay natin siya dito sa T natin. So, again, using that formula, then substituting the T is equal to 22. Then, multiply natin itong 22 times 0.02. So, magiging 30 e raised to 0.44. So, pwede nyo itong i-direct sa calculator. Yun yung mismo. Okay? Or, pwede nyo gawin, ito muna unahin nyo. Okay? So, ang equivalent itong e raised to 0.44 ay 1.55271. So, kapag pinag-multiply mo itong 1.55271 sa 30, ang magiging sagot ay 46.813. Okay? So, therefore, the city population in year 2017 would be about 46,581. So, since na sa given natin is in thousands, so, times lang natin siya ng 1,000. Maging sa first example natin. Kaya siya nag-come up sa 30,000. So, therefore, dapat ang sagot dito, di ba, is 46,581.3. So, syempre, since na wala namang taong decimal o 0.3 or butal, walang taong butal, so, i-trim down natin yan. Okay? So, ibig sabihin, huwag na lang natin siyang pansinin. Huwag natin siya isama. So, kunin na lang natin is yung full number. Okay? So, pasabihin nyo, paano sir kung 0.9? Dapat round up yan, di ba? So, that magiging 46,582. Hindi pa rin. Kasi yung 0.9 is still butal. Okay? Butal pa rin siya. Kulang pa rin siya. Therefore, hindi natin siya pwedeng i-round up. So, still, 46,581 pa rin ang sagot. Okay? So, ito na nagtatapos yung first topic natin. So, thank you for listening and thank you for watching.